If you've ever racked your brain trying to gauge the performance of your software program in a production system and used DTrace to the rescue, you have our next guest to thank. Bryan Cantrill is a computer scientist and a software engineer with a rich career in systems software and building solutions to key problems in distributed computing. His pathbreaking work on DTrace won him multiple awards and a spot in the MIT TR35 list. Today, he is a co-founder of the Oxide Computer Company. Bryan, welcome to ACM ByteCast.
Thank you for having me. It's great to be here.
Great. I'd love to ask you the question that I ask all my guests because I always get fascinating answers is if you could please introduce yourself and, talk about what you currently do and also give us some insight into what drew you into the field of computing.
Yeah, sure. We'll get to what I'm doing in a bit. As you said, I'm the co-founder of Oxide Computer Company. We're taking a very big swing at an old problem. In terms of how I got into this, I'm definitely a child of the 80s, born in the 70s, but grew up in the 80s. And so, I think personal computing was such a revolution in the 80s. And I think like many of my generation, my first computer was a Commodore PET that I used, in third grade and playing Oregon Trail on the Apple IIe. And just computing was it was so revolutionary, and you could kind of feel this revolution happening. I always enjoyed computing as I would say it was more of a hobby, honestly. I enjoyed, writing basic programs and so on, and I took programming classes in high school. I didn't really view it as an academic domain, honestly. This is a little bit embarrassing to say. I just didn't really know what computer science really was. And on the one hand, that sounds ridiculous. On the other hand, if you think that most computer science programs were really only born in the 70s and 80s, it's a new discipline, and I just didn't know that there was something really academic there until I arrived at university. So when I went to school, I was actually very convinced that I was going to become an economist, believe it or not. I was going to get a PhD in economics. I wanted to be a mineral economist. A very strangely directed idea of what I wanted to go do. And I'd always enjoyed programming. And, I really credit when I was looking at schools, I was looking at ultimately two different schools. One had an extremely strong economics program and a more or less non-existent computer science program. And one had an extremely strong computer science program and a pretty good economics program, but not necessarily especially notable. And, parents think that their teenagers never listen to them, and that is only mostly true. And I definitely listened to my mother in particular at very key junctures. I definitely remember my mom saying, you really owe it to yourself to really understand what computer science is about. And my mom is not a technologist at all, so I'm not sure where. I guess it was just the wisdom of years that gave her this perspective. But that turned out to be very prescient. And when I really arrived and took my first real computer science course as an 18-year-old, it just felt like a very big light was going on. For me, the study of algorithms, the fact that you could reason about algorithms, the fact that this was mathematical machine effectively, and the fact that something that I had always enjoyed and had fun doing, namely programming, now suddenly I could program for credit. I could actually do this fun thing that I enjoyed and get course credit doing it. Was just a tremendous rush, and I really fell in love with computer science ever since. I went through kind of a period where I guess the economics washed out of me faster than the academia, because I definitely believed that I would go to grad school and get a PhD in computer science, and was very invested in that path. But then fell in love again with operating systems. Took the operating systems course as a sophomore in school. And what I loved about the operating systems course is that the program of an operating system kernel, it's a really hard program. It's a really challenging program to get right. And I loved that. I loved it's very easy to get this kind of arrogance as a programmer that you can kind of like program anything. And that arrogance leads to a kind of boredom, which is ridiculous because there exist these programs, many programs that are really hard programs to write. And I loved that in the operating systems course. I loved how hard the program was because it's so frustrating when it's not working. And it's so gratifying to finally get it working and to get it right felt very gratifying. So after taking this OS course, I really wanted to go do systems work. When I was looking for a job after my sophomore year, I really decided that I did not want to go spend that summer back at home. Wanted to go work somewhere. And so I had read in, if you remember Byte magazine back in the day, but Byte magazine had an operating systems roundup issue. And this would have been in like December of 1993. And I remember on the way back home to Denver, I grew up in Denver, in O'Hare, reading this article. And in particular, they were talking about all these interesting operating systems that were out there. And one of the operating systems they talked about was an operating system called QNX, which is a microkernel-based system. And I ended up, I guess, getting an email address. I must have found an email address for someone at QNX and basically cold emailed them saying that I would love to come work for them for the summer. So much to my delight, they were willing to have me. And I worked this is in Ottawa, in Canada, and worked there for 2 summers. And especially coming after that second summer, where I again had done really hard programming and had done the bring up of the operating system on a symmetric multiprocessor, which was so much fun and so hard. And by the way, I should define what I mean by hard. Hard is a program that you think you might never get working. That's an example of a hard program. If you have that voice in your head, worried that you're never going to get it working, that's hard. Wherever it is in the stack, whatever it is, that's a hard program. And I definitely had a hard program there at QNX. Really enjoyed getting it working. Was very satisfied, and or just found it satisfying. And really had decided at that point that I wanted to go do operating systems development. That's what I wanted to go spend my career doing. And at that time, and now we're up to like 1995, getting into 1996, if you wanted to go do OS development, really there was one company that was doing OS development, and that was Microsoft with Windows. And then a bunch of other companies that were rapidly trying to figure out how to run Windows on their computers. And I did not want to do that. There were a bunch of reasons why I did not like the OS development coming out of Microsoft. And I really loved Unix. And there was really only one company that wanted to bet it all on Unix, and that was Sun Microsystems. So I went out to Sun in 1996, and that kind of launched my career. So that's how I got into it anyway.
That's incredible. I mean, there are so many nuggets in there that I want to tap into, right? I mean, one finding, I really loved what you said about the fact that a hard problem or a hard program is one that you may never get right. To actually use that as something to fuel your interest rather than lead to frustration in itself is a very unique trait. I don't know if many of us have that. And secondly, I think the piece that you said, I mean, I'm wondering if, you were in an area of software development that was not maybe hotly pursued by so many others, maybe because it was hard or maybe because it was not as sort of flashy. And that in itself may have led to so many great opportunities that you could have pursued. But the third and most important thing that you said was that teenagers listen. I have 2 teenagers, and I wonder if they ever listen sometimes. So at least I'll know I won't stop talking now.
That's it. And I've got teenagers as well, and I think the challenge is you don't know what they're listening to, and they're kind of never listening on your schedule. They're listening on their schedule, but I think they definitely do listen. And it's true. And I think that, I mean, you raise a bunch of good observations there. I do think that it's a real danger. Not that I ever did. Not that I don't necessarily see this as too endemic, but you definitely don't want to follow what's trendy. Or what's kind of in demand. I think it's much more important to find the things that are satisfying to you. And I know that this becomes, people are kind of deride the idea of like following your passion. And I actually don't like the word passion for a bunch of reasons. But I do think it's really important that we are intrinsically motivated by the problems we're solving. We should find solving those problems intrinsically satisfying. And if there's a problem domain in which one finds the problems intrinsically satisfying, that's a problem domain that you should pursue. And I had many people tell me that OS development was dead. People who were domain experts saying that, and this is in 1996, that there's really nothing new to be done in operating systems. And I'd love to believe that my technology was one that helped prove that wrong. DTrace but not just DTrace, but ZFS and we did a bunch of things at Sun at the time, but there've been a bunch of things since then. I mean, you go back to, no one wants to run an operating system from 1996 because operating systems have advanced a lot, many different operating systems. It's not just one technology. So, I think that history is littered with folks who thought that a domain was not worthy of a young person's time and energy because they themselves didn't see new opportunity in it. And I think it's dangerous to talk young people out of their enthusiasm for a domain because that enthusiasm is often required to get to real breakthroughs. And yes, the domain may be different than it was 2 decades prior or what have you. But that doesn't mean that innovation is dead in it. Quite the contrary. That may mean that the domain is really ripe for a new leap forward. So I do think it's important in terms of how we counsel one another. And I definitely tell people, don't make decisions based on fear of what you think is going to happen. You should make decisions based on the things that you find motivating and exciting and worthwhile. And honestly, don't worry about the rest yet. Focus on that intrinsic motivation. And that to me is a path to a much more satisfying career.
I mean, very, very true words. And I think it's, relevant even for folks who are, later on in their career. Many times you come across opportunities where you think that, the new shiny project in your organization is where, all the excitement is. And there are so many opportunities for innovation, even in what you do. I remember one leader in one of my previous organizations would say, you can potentially rewrite your existing well-working software every couple of years and, radically change it and learn so much from it. But one thing I did want to touch upon, Bryan, is, of course, it's very hard to read about, your varied accomplishments without mentioning DTrace. How did the idea for that come about? And somebody who's so early in your career, when you sort of, when you joined Sun, how did you get the opportunity to work on something that was so path-breaking? Or was that something that you identified when you got into it?
So it's funny you should mention that. So I'd had kind of the original foundational idea, namely the dynamic modification of running kernel text in a way that was not actually stopping a program as an undergraduate. And I remember asking folks about why it seems like this is the way you would do it. Like, why wouldn't you do it this way? And the word I got back was like, well, if it were possible to do this safely, it would have already been done. Which I actually accepted. I'm like, oh, okay. So when I actually came out to Sun, the day I interviewed at Sun, and this speaks volumes in many different dimensions. And this is one of those moments where I remember exactly where I was in my life. I was in Bart Smalder's van on the 101 talking to Jeff Bonwick coming back from lunch. And at that point, I was really excited about the opportunity. And I was describing this kind of nugget of an idea to Jeff. And the way I was describing the idea, honestly, was not in the sense of like, I want to go do this or this should be done. It was more, I don't understand why this isn't done. And there must be a good reason for it. I basically have been told that this doesn't exist for a good reason. So my question was, what is the good reason? Because I just don't know what it is. I don't doubt that it exists. And Jeff just said, yeah, I can't think of a reason why we couldn't do that. You should do that, actually. You should come here and you should do that. And boy, was that empowering to hear as a 22-year-old that, not only was there not a good reason why it can't be done, but that I should come do it. I mean, that was it was very empowering. And so when I came to Sun, it was always with that idea at the back of the brain. Now that I came to Sun in 1996, we didn't start until 2001. I spent the next 5 years, more or less, really doing a bunch of work that I felt that was a higher priority work in the operating system, and then learning a lot of what we needed to go do to actually tackle this problem. But it got to the point where I got such a clear idea of what we wanted to go do that someone would have a problem and I would say, actually, DTrace would solve that problem. And of course, DTrace didn't exist at all at this point. I mean, this is just a ridiculous thing to say, especially as somebody who's just suffered their day through a painful debugging exercise. And again, one of these moments, remember exactly where I was, who I was speaking with. A senior engineer, Tim Marsland, had just debugged a challenging bug, or had been struggling with a challenging bug. And I remember saying to Tim outside of the restaurant that we used to frequent, DTrace would solve that problem for you. And Tim just gave me this kind of exasperated look and said, well, and he's English, so I'm not going to imitate his accent, but it's a very distinguished accent, but he was very exasperated. He said, if DTrace would solve this problem for me, then why don't you just go write DTrace? And it's like, okay, yes, we need to stop talking about what DTrace is going to go do and actually go do it. And so we started shortly thereafter. November of 2001 is when we started working on it. And it still took, I would say, on the order of 6 months before we got to, whenever you start something bold, there's always the fear of failing. I don't care who you are, what you're doing, that fear, that doesn't necessarily need to consume you, but there's always a fear of, I'm going to invest a bunch of time and energy into a dead end. And with DTrace too, there was a little bit of that. And we really needed to negotiate for extended time to do something that might not work, that might actually not be viable for some reason. And it took on the order of a little bit less, probably like on the order of 3 months, really 3 to 4 months, before we had these proof points that indicated, okay, this is definitely the right direction. And I think as an engineer, especially when you're doing something bold, you really look for those proof points, almost omens, right? You look for these good omens early, indicating like this is actually the right path, that this path may be hard, arduous, long, rocky, but the payoff will be substantial. And we did get those, but it took a couple months to get there before we got those proof points, and then spent another 3-4 years really fleshing out the technology completely.
I think what you said earlier about being empowered, especially as somebody early in their career, is so true, right? And that's what I was sort of tapping into earlier, saying, how do you get those opportunities? A lot of the times you feel when I'm someone new, I'm going to get to work on a small piece of a small puzzle, and I may not even know how it fits into the larger sort of initiative or the goals of the company. But as you were working on this problem, one thing was obvious with your conversations is that, you already had your quote unquote first customer who was saying, go out and build this and, I'd at least experiment with it or try it out. What were some of the other considerations or even constraints? As you, obviously Sun was a massive company at that time, and, you were almost working on this research project. What were the other things that were on your mind as you were wrangling this problem?
Well, so honestly, and I think this is where we always do our best work. I had one customer in mind, and that was me. I was really developing the thing that I wanted to be able to go solve the problems that I needed to solve as part of my job as a kernel developer. And I originally had joined in the Solaris performance group. So as someone who was focused on the performance of a system, I was developing the tooling that I needed to do that job. And when you're developing for yourself, when you are the customer, you've got such a crisp idea of what to do. And I always believe that we do our best work when we are our own customers. And ultimately, I think that even some of the legends in the field, I think like someone like Steve Jobs, ultimately Jobs was designing for himself. It's just that he happens to have good taste that was applicable to a broad cross section of folks. But I think we do our best work when we design for ourselves, and so you want to kind of feel, and you hope that you represent a larger demographic than just yourself. And fortunately, in this regard, I think I did represent a larger demographic than just myself. And in particular, another light that went on a couple years later was realizing that actually, while I was originally developing it for myself and doing kernel performance work, the much larger value of it was actually finding system level problems, applications that were misbehaving. And the symptoms of those misbehaving applications were often so deep in the stack that you actually needed to be able to instrument the operating system kernel in order to actually reason about this higher level problem. So I think that the other thing I would say is that all along, and I'm a strong believer in this as well, we were using our own technology. And I think we as a discipline have gotten actually quite a bit better about this over the years. We have kind of grown out of this throwing it over the wall, big software release kind of a thing, people kind of frequently deploying into production and so on, which is good. But it definitely yields a higher quality artifact when we ourselves use the software that we are creating, which is something we definitely did as part of DTrace for sure.
Yeah, I think it almost should be on a plaque. You are your customer. I absolutely agree with you, where if you feel the pain of a certain problem enough that it disrupts your day-to-day sort of piece, you will go out to find a solution for it, and possibly the best solution for that problem.
You're right. And I think in the balance to strike there is you want to be using your own technology, but you also need to still have the freedom to improve it. So there's this kind of idea that you want to make a software engineer carry a pager so they kind of feel the pain of anything that's broken that they deploy, which only works if they are similarly empowered to fix that brokenness. So what you want to avoid is punishing engineers for technical debt that they can't fix, which is the kind of extreme of this, isn't actually productive. That just makes miserable people. And what we had this kind of luxury of being able to use the technology, but then also being able to fix the things that needed to be fixed. And there were years, I have to remind myself of this because this was so many years ago, but there was a really protracted period of time where every time I used DTrace to find a problem, I would find the problem, but I would also find a bug in DTrace. And I would think to myself, Jesus, am I ever going to be able to use this tool? And often, these are small bugs, not huge issues. But you think to yourself, am I ever going to get to the point where this thing is just robust and works? And of course, it did get there, but it took a little while to get there. And it got there because of that feedback loop and coupled with the freedom to actually fix the problems that we found.
Yeah, and that's a really, really good point. I think that the ability to identify the problem, but also have that the power to be able to go and fix it, and not be constrained by other restrictions by an organization or a technology choice, is very important. One of the things that I was reading about as I was, reading about DTrace and the history, of course, now the word observability is bandied about. We use it a lot. It's supposed to be super critical for every business to be considering. What do you make of it, and how do you feel? Has it grown, or has it changed and morphed in its, is our understanding of it?
Yeah. Well, so it's funny you mentioned that because I'm not claiming that I necessarily invented this term with respect to software, but I definitely don't remember anyone using it before me.
Wow, that's amazing. I did not know that.
So, it's hard for me to know. I mean, I talk about it a lot in this 2006 paper I had. I definitely was using it long before then. In part because DTrace was a new kind of a thing that we did need to have a new way of talking about. And we used to say that DTrace was concise answers to arbitrary questions. And that property of being able to answer questions about the system, I called observability. And again, it's the kind of thing that, I don't know, maybe I did hear it from someone else. I don't think so. I certainly, but I don't actually know. One of the things that drives me a little bit bananas is that kind of people go to the Wikipedia article for observability, which has really got nothing to do with software observability. It's a control theory construct that has got zero to do. And they kind of, provide this Wikipedia definition for observability, but it's like, no, that's actually not what observability is at all. Observability, to me, software observability, system observability is the property to actually observe what the software is doing. Because without dynamically modifying software, we don't actually know what it's doing. If I show you a CPU executing software, without actually modifying it, you don't know what instructions are being executed. And to me, observability is the property by which we can understand what the system is doing. So, and again, not that I was necessarily claiming to necessarily invent certainly not the concept, but the nomenclature, I don't know if anyone used it before me. Again, I'm sure someone did, or I don't know. I don't particularly care, actually. But I do think it's kind of funny that now the term has become much more broadly used, and now kind of people are fighting over, what is the true definition of observability, which I think is, honestly, I think it's great, actually. I mean, I think it's great that there are so many people that are concerned with how we understand these systems, that there is disagreement over the terminology. It's probably a good sign. So I think it's probably a good thing. But it definitely has taken on a bunch of different shades and tones and so on. And different people have got different definitions. But to me, it boils down to the ability to answer questions about the system. And then there's a very kind of important implication there, which is that you need to have somebody who's asking the questions of the system. And one of the challenges that we have is asking questions of the system is hard. It requires an understanding of the system. So how do we allow people to easily ask questions of the system and explore and have those answers then prompt new questions that allow them to get to understand the behavior of the system, which is what we're really trying to understand. We're trying to understand putatively, presumably pathological behavior of the system, but we're trying to understand system behavior, dynamic system behavior. That's what observability is about to me.
Got it. And I completely agree with you. One question I do have, though, is has it become more sort of crucial, or more of on the minds of business owners now, as the systems have gotten to be more complex and more distributed, with cloud computing? Why is it so important today, as compared, or why is it talked about more today as compared to maybe 20 years ago?
Well, yes. I mean, it is much more important. And these distributed systems make it really important, because when these systems misbehave, especially, we are now have got companies that, and we saw certainly early shades of this in the late 90s, but we have companies that are many companies that are entirely software as a service companies. And when their software is unavailable, their business is dead. So that is that serves to really focus folks. And the idea of you have outages, but then these kind of transient failures. I think as the Mark Andreessen's 2011 prophecy of software eating the world, as software is eating the world, our observability of that software has become ever more important. So it is more important, which is great. There are a bunch of companies and projects and so on, technologies that see that opportunity, and that's great. I do think one of the challenges that we have, and this is just an evergreen challenge, is people generally, they don't want to have outages, certainly. They don't want to have poorly performing systems. But it can be more of a challenge to get people to invest upfront in what's required to not have that. People are more reluctant to make longer term investments. And that may be investments in terms of money, and maybe investments in terms of time, in terms of energy, in terms of thought. And getting people to think about the debuggability of a system as a system is being developed is really challenging, because everyone is focused on getting the system deployed, and not necessarily as much on what is going to happen when the system fails after deployment. So I think there are a bunch of folks that are focused on the problem, and I hope that we can get a kind of a longer term thinking that allows an increasing number of people to be willing to make the necessary investment for these systems to be robust.
Right. No, I think, that preventative sort of hat that you need to wear when you're sort of building software systems, it's always hindsight seems to be 2020 in that case. But going back to the point about, asking the right questions of your system, uh, do you have any thoughts at all in terms of, I mean, I've heard of, metrics, events, logs, and traces to be like the gold standard of measurement in this field of observability. Would you help us understand, like, what do you think are the crucial, maybe questions we need to ask of these systems? And in turn, what should we be measuring in order to be able to answer those questions?
Yeah, well, it's not. I think we don't want to kind of falsely dichotomize what we need, and I don't think it's kind of is it metrics versus logs or traces versus events, what have you. I think that is um, that's us operating at cross purposes. I think that we, when a system misbehaves, we need to understand what it's doing, and all of those things can serve as valuable steps or valuable sources of data or information that can allow us to ask questions. So, metrics can allow us to ask interesting questions, but but if I can't actually ask the follow-up question, I see this 700 millisecond outlier that happened. Why did that happen? It's like, well, we don't know why that happened. Or, not being able to kind of ask that next question, not being able to dig deeper to get that question answered. We run the risk of having performative metrics, for lack of a better term, where we are gathering these things to give ourselves dashboards, but it's actually not giving us real insight into our systems. It's only, and in fact, to the contrary, we are overloading or being overloaded with stimulus. And we can sometimes we have so many metrics in the system that it can be hard to see what is actually going on. And I always look. I think that I always think that history can teach us a lot. And in the 3 Mile Island disaster, there was a relatively simple problem that was very hard to see because the operators were so overloaded and overwhelmed with all of the cascading failures of that this relief valve was in the wrong position, and the solenoid was effectively telling them something that was the opposite of what they thought they were. The light rather was telling them something that was the opposite. The indicator was the opposite of what they thought it was, and they became effectively overwhelmed. And it took a shift change and someone taking kind of a clean sheet of mental paper, if you will, and thinking about what they knew about the system to be able to ask this question. The metrics were not guiding them to the right question. In fact, they were overloading them. So I think we have to be careful about looking for a panacea in there. There's not a panacea. These systems are complicated, and it is about how do we answer questions about the system. And I think also we should serve, and I'm not sure to what degree this happens in all circles, it certainly should. It should also serve as a check against complexity. For those software engineers who haven't already figured it out, they will at some point in their career. And that is, complexity is the enemy. We need to make things as simple as we can for them to function. And there have been many revolutions in computer architecture, computer science, computer systems that are effectively revolutions in simplicity and making the system much simpler and having less, not more. And when you have less, it is easier to reason about, easier to fit in your head, and easier to ask the right questions.
Well, that's an excellent mantra to sort of live by, especially in terms of in any sphere of life, I would think. But yes, simplicity will solve a lot more problems before they actually become problems. But one of the, I mean, it seems like, this would be a question that comes up in any software discussion nowadays is the use of ML, right? It seems to be the charter of every business out there to use that intelligence and to make their systems better, or to be able to, use machine learning to really enhance what they can offer. Where do you see the applications of ML in this space?
I don't know. I mean, I think that part of the challenge, and this is not my domain of expertise, just to be clear, but I do think that part of the challenge is that I don't know how you would train that. Training the kind of the training data set is so important, and we are, to me, these systems are so complicated and their emergent behavior is so difficult to reason about that I don't know how we would train for assistance in pattern identification, which is that's what we're talking about when we talk about ML. I mean, I think that we talk about learning and artificial intelligence. I think we do ourselves a great disservice by thinking of it as intelligence and not thinking of it as pattern recognition, which is what it is. And it is sophisticated pattern recognition. So how can sophisticated pattern recognition help us in asking questions of systems? And I don't know the answer to that. Which is not to say that it can't. I think I'm sure it probably can, but it is not obvious to me what that answer would be.
Got it. I mean, it seems like, like you said, it's not that it can't be done. Maybe it hasn't been done yet or hasn't been thought about enough. And so maybe the next young student that comes in from university trying to solve this problem will have a shot at it. But I did want to talk about one other part of your career that I observed, Bryan, which is you have a particular interest in open source. I mean, it seems like a lot of the solutions that you build are for the open source community. How did that come about? And I'd love to hear more about your philosophy on that.
Yeah, well, I mean, so as a software engineer, and I mean, I remember being a student at school, just eagerly awaiting the source license to the operating system. So this is in the era of strictly proprietary operating systems, and we had a research agreement with Sun that allowed us to get allowed us to peek inside the source code, and boy, was it valuable! And it was so essential to understanding some of the problems that we had to see inside the source code. So I certainly never forgot that feeling. And as an engineer, just found that source code availability is essential. But when I arrived at Sun, it was still a proprietary system. And I got to participate in something that was pretty fun from 1996 to 2004, and that is we open sourced the system. The system became open source in, well, I guess, early 2005. I guess it would be January 2005. And DTrace was actually the very first thing that we open sourced in the operating system. And it was really fun to get the source code out there and to make make a contribution, make something that was meaningful. It was really hard to open source proprietary software. I think that sometimes outsiders underestimate the complexity and the organizational willpower it takes to open source the operating system, open source anything, open source a body of software, in part because when an all proprietary company that is not paying attention to making their source code available will sign all sorts of agreements and incorporate all sorts of other proprietary code that prevents them from open sourcing it. And indeed, that was the case at Sun. There were, they can't remember the exact, it was on the order of like 300 different agreements that had to be chased down. And there were parties that couldn't be located, companies that had gone out of business that we couldn't negotiate with to open source their elements that we had long since licensed in perpetuity inside the operating system. So, there were some things that when we open sourced the operating system, there were actually some things that we could not open source, little things, stupid things that we couldn't open source that as an open source community, we later developed afresh. But that whole experience, which was an exhausting experience, really seared in my mind the importance of open source. And we do better work when it is open source. We do proprietary software allows for this kind of natural monopoly that a software vendor has, and they just begin to behave as a natural monopolist behaves. And there is good proprietary software out there. Certainly, it is the exception rather than the rule. So I've always believed that software being open source allows for a really important kind of check. And it allows, as a technologist, it allows me to integrate someone's technology without fear because I know that I've got the source. So I think that, I kind of came up in this era of proprietary software that then flipped to become open. And it felt like the open source revolution was done, was over. But then with the rise of cloud computing, we saw a different kind of angle where open source projects were now being run as proprietary services because the licenses didn't preclude that from happening. And that I felt was dangerous and corrosive. As I feel some of these, because for years, Google and Facebook and Amazon didn't really open source very much. It's hard to believe now because Google has contributed so much, but there was a protracted era where Google contributed really very little, and they consumed a lot of open source, but they didn't actually produce anything. But that changed over time, and I feel it has been changing over time. Certainly at Facebook and even at Amazon. Amazon was not open sourcing anything, but has begun to change in that regard. And as those changes were happening, meanwhile, these other software companies that had grown up as open source software companies now are viewing the license as a way to effectively monetize their software, namely by restricting the way it's used. And that's a really unfortunate development. That is antithetical to the spirit of open source, antithetical to the letter of open source, actually. It's just not open source. And I am optimistic that this will be a blip in history. Open source software, part of the beauty of open source software is that it's information. It survives in perpetuity. It can't be deleted. It can't be removed. And as a result, these open source, in the limit, open source will effectively conquer every domain. That is, say, every software domain will have open source components at its core. I very fundamentally believe that. And I think that some of this regrettable recent trend in the last 2 years or so, I think will be a blip. But I certainly believe in the power of open source more than ever.
Yeah, that's incredibly, heartening and encouraging. But as an entrepreneur, Bryan, and now as a co-founder of a company, how do you see, open sourcing the work that you are creating? Working alongside the fact that you do have to run a for-profit company.
You bet. Well, so we're a computer company. So we've got God's own open source revenue model. Namely, we make computers. That's what we're going to make and sell. And we are incentivized to open source our entire stack because our entire stack is designed to run on, honestly, our computer. That's how we make money. We make money with the metal. So we hope to serve as a model in that regard because I'll tell you the true last domain, the last holdout for proprietary software is in this very critical but not well-known layer of firmware. And firmware right now is broadly very, very proprietary, and it is causing mayhem, all sorts of mayhem. It's a security problem, it's a reliability problem, it's an economic problem. And we are really hoping to serve as a model with an open source stack that includes not just all of the system software that we're building rack scale machines. So we are building the kind of the minimum buy from Oxide will be a full rack of compute and storage and networking of our own design using off the shelf silicon, so using x86 based silicon, but we are developing all of the software, our own hardware root of trust, our own service processor, and so on. All of that software will be open source. And from our perspective, it's easy. It's not an economic argument at all, because I am just not at all concerned. In fact, if someone wanted to take our software and get it running on some other hardware platform, sure. Good luck. But great, honestly, great. Because the key is that a customer that would do that, take our software and go through all of the technical challenge of getting that to run on other hardware, that was never going to be a customer of ours anyway. So their contributions to our community is great. That's a contribution that we wouldn't otherwise have. And I think that's what folks lose when they think about how do I build a business around open source? It's like, that's the wrong question. When you're building a business, you are developing a product that people will pay for. The open source vector it's not about monetizing open source. It's about using open source as a way of broadening your community, broadening your funnel, accelerating your existing business, not building a business around that. In that regard, I liken open source to a remote-friendly workplace. We all know that especially now, a remote-friendly workplace is the right answer. It allows us to find talent wherever that talent might be. It allows us to be more family-friendly and so on. So there are lots of reasons to be a remote-friendly workforce. How do I monetize a remote-friendly workforce? Like, wait a minute, what? It's kind of orthogonal to a remote-friendly workforce is a tool that we use as part of running a business. It's not the business itself, if that makes sense. And that's what I feel people have. That's what I feel, and if I may just be generational for a moment, that's where I feel this kind of younger generation a little bit. I'm going to sound like, I'm going to sound like the old man that I am, but I feel that there's those folks that, put it this way, those folks that did not grow up in proprietary software are recreating a bunch of the problems that open source software solved. And they're not seeing the fundamental problem here. The fundamental problem here is you are trying to directly monetize open source software. That's not going to work.
Thank you. I think that was an incredibly lucid answer, and certainly gives us a lot to sort of think about. I have one other question for you, Bryan, and it's somewhat it's a little bit different from just your overall career as a software developer. But one of the things that I noticed through some of the conversations of yours that I've heard is that Jeff Barnwick played a really important role in your growth as a software engineer, right? That mentorship and that guidance in your early career seems to have really, blossomed you into some of the initial principles of software engineering that you learned. How do you feel that has really changed your life, and how do you feel you've passed it on to others?
Yeah, and I think it's more than just mentorship. It's more it's more influence, actually, I would say, than more. Really the service that Jeff in particular played for me was opening up and allowing me to flourish, contribute, take on hard problems. So I think that in some regards, more formal mentorship is important too, of course, where you are much more, in the kind of the mechanics of showing people how to do things and so on. But I think we really lead by our example, and it's very important that we are inclusive and encouraging of new thinking, of folks that are outside the domain, of people that don't know this stuff yet. I always loved what Jeff had to say about it. Was very important to Jeff that we are able to explain things to new people, as he said that people aren't born knowing this stuff. The thing that I really see that's striking to me is kind of the way people treat knowledge. And is knowledge something to be shared, or is knowledge something to be hoarded? And the people, especially if you're a young person, but the people you want to be around are the people that want to share knowledge, that are excited to help, that when when you know something, it doesn't, or they know something, it doesn't threaten them if you know it too. And that sadly, that's not everybody. Sadly, there are people that want to use their knowledge and they want to hold on to their knowledge because God forbid you get the same knowledge that they have, then what's their role? Which is terrible to say, but there are a lot of people do implicitly or explicitly do that. And the engineers that I want to work with are those engineers that are very giving of their knowledge, that they are incentivized to make things easy to understand. I think that, you get this kind of perverse incentive where people who want to hold on to their knowledge are also incentivized not to actually document what they know, not to explain it very well. You don't want any of those incentives. You want people to be incentivized to share what they know, to document what they know, to uplift other people, to help other people. So to me, it's way more than just like mentorship. It's all about creating an environment in which newcomers can thrive, and can people who are excited and motivated and willing to work hard can uplift themselves, and pass that on to other folks and to another generation. And I think that is more than anything, it's that zeitgeist that I very much got from Jeff and have tried to pass that on to others over my career.
That's such a golden nugget of advice, both to folks who have that knowledge to share, as well as the ones who are seeking that knowledge. It's so important for us to coexist and be able to grow from that experience. This has been an incredibly eye-opening conversation, Bryan. For our final bite, I'd love to know, what are you most excited about in the field of computing or observability or whatever we may call it over the next 5 years?
Well, I mean, and this is where I'm gonna talk my book, as the VCs say. I'm very excited about the problem we're solving at Oxide. So we are developing this rack scale machine, as I mentioned. We are really trying to develop the system that I've wanted to develop for my whole career, which is rack scale computing, integrated hardware and software, taking a real systems approach. And this is a really hard problem. This is something that, honestly, the origin story here is pretty funny in that when first thinking about kind of what we wanted to go do next, and I was recalling a venture capitalist that I had known from years prior, and going back through my email just to remind myself of his email address. And the last email he'd sent to me, like maybe 2 years ago, 2 years prior, was, "Hey, look, Bryan, just as a reminder, I will fund anything that you put in front of me." I remember thinking, like, is that true? Is that is that actually a literal statement? And if that's true, then as I'm thinking about what's next, maybe I should actually be, and it sounds trite to say, but I should actually solve the problem that I would solve if I were unafraid of failing. What problem would I solve if I were not trying to, if I knew that I could raise money to go solve this problem, what problem would I solve? The problem that I wanted to go solve is I wanted to actually go bring all these innovations from the Googles and Facebooks and Microsofts of the world. I wanted to bring them to the mainstream enterprise market and actually develop a new computer company. That's where that's what's in my marrow. And fortunately, and just blessed by the fact that lots of other great technologists have that same fervor, that same passion, that same mission. And we were able to raise the money. Ironically, by the way, the VC that sent me that was one of the very first to just totally puke on this idea. He was just like, absolutely, I don't know, I would never fund that. That's a terrible idea. I'm like, oh, okay. I'm actually really glad. Clearly you were lying to me when you sent that email, and I'm really glad that you did, because that actually gave me the confidence to go do this. So that's kind of a little irony, but I am really, really excited about it, and I feel that it is by far the hardest problem I have been associated with in my career. So ambitious, so much at so many different levels of the stack. I joke that like apparently today is not going to be the day where I know how computers work, because every day I'm learning something, something incredible, some incredible new domain that all of us are effectively built upon that isn't well known. I mean, there's so many things. It is such a miracle that these machines work at all. It's amazing. The hardware and the software, there's just so much. And to me, that is so exciting. And it's exciting too, because this is, on the one hand, this is like it's kind of how I got into this business of going into OS kernel development at a time when I was told there was nothing left. And we are now a computer company when people have kind of implicitly said that the innovation there is dead, and it's definitely and emphatically not. The innovation is very much alive at every layer of the stack, and it's really, really exciting. And there's a lot of really exciting stuff happening. So I think I've never been more excited for the next 5 years than I am for these coming 5 years. It's really going to be a terrific time.
I mean, your excitement is absolutely palpable, and it's wonderful that you've sort of come a full circle in terms of that opportunity and that the being in that situation where you've seen the opportunity that many others haven't. We wish you well, and thank you so much for joining us at ACM ByteCast.
You bet. Thank you so much for having me. Great conversation.
Likewise. 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 Likewise.